The history of electronic computers has been forged by such heroes as Alan Turing, John von Neumann, Steve Wozniak, John Carmack, and Pepes.
Welcome to Pepes World, the show where sorry I'm late. I didn't get much sleep last night. He's a hungry boy. What a lovely day it is outside. What the fuck am I gonna do today? I feel like a light project for once. Do you find it a pain in the ass when you want to read the terminal output of one of your projects and you gotta lug around a huge fucking laptop or something? That's why today we're gonna make a pocket-sized dumb terminal. That's right, a pocket-sized dumb terminal. Just like I did when I electrified my nuts back in episode 8 and 9. And we've got a little testy box, so let's go sit outside and get some numbers. Now when you're screwing around with terminals and TTYs and stuff, what you're doing is using a fake serial terminal. One of these, which later evolved into one of these, which eventually became this shit. So what exactly are we going to be making today? What do we need? Well, we're making a terminal which only receives things. We're not going to be sending anything. So the wires that we need are going to be a receive wire, an RX wire, and a ground wire. And the reason we have to talk about ground is that the two devices, our project and our terminal, have to have the same ground.
Modulating data.
So how the fuck does serial actually work in the first fucking place? You've probably seen that there's no clock signal. How the fuck does that work? How can you synchronize data between two different machines without a clock? You see, a serial connection doesn't need to have a clock which always ticks along the line. The two ends both agree on which speed to work at. In other words, how many beeps per second or baud. This can be done through various means. Typically for us hackers, we're just going to specify, 9600 or whatever. When the sender wants to send some data, he sends what's called a start bit. And that means the receiver knows that something has changed on the line. So I can look at the voltages going up and down at the right speed, match them to some bits, and well, that's pretty much it, really. You've got options for parity and all kinds of things. Why am I telling you this? Well, if you've got a memory more than a couple of fucking seconds, you would remember that I said that they have to negotiate the speed up in advance. Well, dial-up modems have got a thing for this. They do what's called handshaking when they talk to each other and go, bing, 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 ba-dum, ba-dum, ba. Surely I've got a dial-up modem in here somewhere, eh? Ah, fuck. And through some negotiations, they work out which speed to go at. What if you can't do that?
Pepe gets an idea.
What we're going to do is we're going to build some smarts into our dumb terminal. If you've got bits coming in which are at some rate that you don't know what they are, why don't you just time the microseconds between the bits and work out the baud rate? Sure, you might miss out a character or two at the beginning, but who fucking cares? It means you don't have to configure everything, right?
Building stuff with your shirt off.
So, what components do we need for this? Well, we need an Arduino, and we need an LCD screen. And we're also going to need some batteries. And we're going to be using an 18650 battery. Oh, but Pepe, why aren't you using a 9-volt battery? Have you seen the fucking specs on a 9-volt battery? They're piss poor. You can get 20 times the longevity by stacking AA batteries together. Yeah. Oh shit, boss, and don't even get me started on the volts.
Oh no, not maths!
Shut up, cunt, I'm trying to record a voiceover.
Okay, well, serial has changed over the years, right? It's not quite the same as what it used to be. These days we have what's called TTL level, which is 0 volts, to 5 volts. And we also have CMOS, 3.3 volts. But serial actually started off being like, was it like negative 15 volts to plus 15? What we're focusing on today is the TTL level and the CMOS level. Wait a minute, isn't the 18650 only 4.2 volts? How the hell is that going to handle 5 volt logic? There is some complications when it comes to TTL and CMOS. For example, you could have a device which is expecting a 0 volts for a 0 and 5 volts for a 1. But the guy that's sending this data might want to send out only 3.3 volts. The receiving chip here, inside his head, he's going to have a tolerance. Could, in theory, get any voltage between 0 volts and 5 volts. So what it has is it has thresholds. What is it, like about 1.8 or anything above, say, like 2.8 or something like that. And it has a dead zone in between. Really, you have to check the data sheet on what the actual thresholds are. If you get a chip that runs on 3.3 volts, and he's not powered very well, and he can only spit out, say, I don't know, like 2.6 volts, thinking it's really shit hot, you can actually run into problems because he wants to send out a 1 and it's only going to fucking arrive in the middle of this dead zone here. And the receiving chip's just going to not really know what the fuck to think. So how the fuck are we going to deal with this problem? Oh man. Well, I'm not. The truth is, I don't care because it's me that's making the project, so I can just change this at will. We just need to make sure that we're not sending too much voltage into the Arduino's I/O pins. And that's pretty easily solved. In fact, half the time it doesn't even give a shit.
Building stuff with your pants off.
Now, if you want to deal with like all of these fucking pins here and shit and making headers and all that kind of stuff, be my fucking guest. But that's just bullshit. Me personally, I can't be fucked. So I just got one of these little shields off AliExpress. They only cost like $1 or something like that. Who fucking knows? I don't even know. And so they easily connect up onto your Arduino like this. Then we get a box. We put our Arduino in it. We put in our battery. And then we shake it all up. Now I'm just giving you shit. We need to have our Arduino here. Got our project over here. Connect the ground to the ground and the TX pin up to the RX pin of our Arduino. Now in order to do the serial timing stuff, we need to have a pin which joins up to the serial pin like this. As we set up an interrupt there, which basically just fires off some counting shit, and we eventually work out what the timing is from there. We can't do the interrupting stuff directly on the serial pin because that fucks up with the serial library, yada 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 yada. I fucking tried it, it doesn't work. The easiest way to do that is to join these two pins together somehow and then have them go off to the TX wire of your project. Do I really need to show you a how-to guide on how to join two wires together? Hey Pepe, can you tell us a really neat and tidy way of joining two jumper wires together that looks really good? Yeah, sure, it's called Get Fucked, and twist them together with some side cutters and then solder them together. Okay, neat, so we've got our three-way connection. We've got, this will be going off to our project's terminal TX pin, it's transmit, and it's going to go into two Arduino ports. Neat. And we need to have another pin for our ground reference to the thing that we're trying to sniff. So this will go off to the ground on our other project. We need to get the positive rail from the 18650 battery and stick it to the 5 volt pin. And then we stick the ground to the ground. Ugh. Now, if you're fortunate, you should have a trim pot on your little LCD screen thingy there. I do. Thank fuck for that. Alright, so... Alright, so let's say you've got your ground wire and your data wire for your receiving data. We're going to make some software for this thing, right? Come follow me.
Pepes going to teach you some C.
Alright, so the majority of this program here deals with the timing, right? Because that's the hardest part of this whole damn thing. Being a terminal is easy. Okay, right, so it's pretty obvious they would include the liquid crystal library, and we'd set it up on our pins, and we start using the serial built-in library API thing. Now, I could have done this in many different ways, but to make things simpler, what I decided to do was make it simply start at a very low baud rate like this, and then simply look for the shortest wavelength it's ever seen, and then adapt the serial rate to that, as opposed to trying to do something more complicated where it would slow down eventually and keep losing bits. And if you start talking to this thing at a slower baud rate, well, just reset your terminal. Who gives a shit, right? Alright, so we've attached an interrupt to the pin which we've physically connected to our serial pin. This is what doesn't work if you simply attach an interrupt to the serial pin. Things just screw up, right? So we've set an interrupt to fire on voltage falling. We've got our interrupt service routine right here, and we record the current time in microseconds, and we also save what this value previously was. That way we get 2 points in time, and using those 2 points in time we can calculate the wavelength, and I cut it in half here just to make the maths easier down the line. Now as shit's reading from the terminal, this loop here is going, off into the side. Our interrupt might be firing, but this is what the CPU is doing for its main day job. Alright, so what we do is we copy that wavelength to a new variable. Why do we copy this to a new variable? Well, our interrupt service routine could interrupt this code at any fucking point, so we want to make sure that we have a variable which isn't fucking changing on us. Multi-threading's a dick. If you don't believe me that this is something you have to do, go and do it without copying the variable to a new one. See how far it gets you.
Concurrent programming.
And just in case you don't know how to convert between wavelength and sample rate, what you do is you just get the speed of the medium and then you divide it by the wavelength. That'll get you how many times it wiggles per second. Now, of course, we don't support any arbitrary bit rate, right? We might in the software serial library, but this is hardware, right? So we just have a routine here which just finds the closest supporting sample rate. And that's it's pretty easy. It's just looking for, some rough ballpark figures, and it goes, oh yeah, it's over 9,000, it's probably close, it's probably going to be 9,600. Unless it's like fucking way over here, then, just, you can see what it's doing. And then what it does, it goes, yeah, okay, is this faster than anything I've seen before? Oh, yep, it is. So, let's change our baud rate to this new one, and then away we go. Okay, and you can see down here, it says, B terminal, which is where it actually does its main job, show letters on the fucking screen. Alright, so, have a look at this ASCII table. Why, Pepe? Why should I look at the ASCII table? No. Oh, what's this? Line feed, tab, carriage return. ASCII was originally meant for terminals, right? And which is, you can basically think of it as an electric typewriter on the end of a fucking wire, right? Those first couple of ASCII characters are actually how the receiving unit would know to move its cursor up or down or clear the screen, etc. Take note of carriage return. And take note of form feed, right? Form feed is when you actually get the entire form and you feed it through, right? Which is the modern day equivalent of clear screen. Now looking at the code for our B terminal routine, you can see here that it simply looks for those special characters. If it's none of those characters, then just write it to the screen with the ASCII library. Who cares? But you can see here we're checking for our form feed, in which case we do a clear, and we've got our line feed or our carriage return or even a home, which just puts the cursor up to the corner. What's this line variable here? Well, these LCD screens, right, they're pretty much always coming with 2 lines. So what happens when you do a carriage return? It goes down 1 line. What happens if you do another carriage return? Well, she could slide up, but I'm too lazy to implement that, so I just made it go back up to the first line again. Alright, so let's plug it into some stuff.
Raspberry Pi, Arduino, YouTube, 3D printers and drones. Like, share, and subscribe.